Hello, hello, hello. Hello, 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 hello. We just paste the link in the Discord. Hello, everyone. Today is date 34 of my C++ DSA journey. In today's stream, we will revisit some problems. After that, we will try some new problems based on binary search. And today, first, we will revisit three problems. After that, we will try a new. According to the roadmap, we have to only solve one new problem, but maybe I will touch it again today because we have to, pick a variant of the topic binary search, like some variant type problems of it, some variants of a problem of binary search, because we should not give that much time to the binary search, so we have to finish it in a less amount of time. And yeah, get onto the new topic that will start as the new topic name is the new topic name is let me just show you. Yeah, the new topic that we start, the name of it is strings. Okay, so before that I want to like do a good number of problems of binary search, so because of that I am thinking to do the things in that way, because today I will solve this problem. Okay, the single element in a sorted array. After that, there are not so much problems to solve in binary search. After that, sorting has been started, and I think binary search is already ended, and after that strings will start very soon. So before the things like change, I was thinking like, why not do some like good number of problems in which binary search will be used. So because of that, from a past 3-4 days, I'm doing this, following this approach to like solve binary problems in a good number of, taking a good number of problems. Because of that, even if it's against the roadmap that I want to follow, because some problems of binary search are not that much harder, right? If we see it in a way, then we will find that they are not even that much harder that we think about it, because it's just an algorithm, right? Instead of using linear search. Okay, so first we will revisit some problems. After that, we will solve new problems today. And yet today our rating, I have seen that I think we have surpassed around 1 lakh people again. It's around 24 lakhs today. Yesterday it was something around 26 lakh 11,000. So the first problem that we will revisit name is find the peaks, in which we will use, yeah, we will use for loop instead of binary search, because in this binary search can't be applied, because we have to find the number of peaks, and peaks can be present on the last index of the array also. Like there can be more than one peak present in the array. tried to solve it before with binary search, but it was failing only one test case. Sorry, it was passing only one test case and failing the other. Like it was passing this test case when I used binary search, but when I used for loop for that, it ran. And a peak can't be present on the very first and very last index because we are given a zero index array named as mountain. Our task is to find all the peaks in the mountain array. Return an array that consists of indices of peaks in the given array in any order. And here are notes given. A peak is defined as an element that is strictly greater than its neighboring elements. Means it should be greater than its neighboring elements. Okay. And here 4 will be compared with this and this. So when we compare this, then we get empty array because okay, 4 is more than the neighbor which is in the left side of it, but it is not more than the neighbor which is in the right side of it from it. When we compare the right side element with the 4, then it is not more than, it is just equals to. Because of that, we only return in the output as empty array. Okay, so before starting, just checking the voice, how the voice is coming. It's a very simple problem. So first we will create an empty vector inside that. If maybe there are more than one peak values, then we can store that value in the store the index of that value. Okay, not that value, just the index of it in the new array. So vector. First we will create an empty vector of type integer and named as a result. And after that we will traverse the array using a for loop from the second value to the last value to the second last value. Okay, I less than n minus 2, not n num size minus 2, right? Because we haven't created any variable which will show the number of elements present in the array. So instead of this we can use this function and I plus plus. It will grow from the second value till the second last value. And beside that we will check if there will be a condition check if nums I minus 1 is less than nums I index like current index and current index nums I is also more than nums I plus 1. Okay, means it should be more than its neighboring elements, like it should be more than I minus 1 and I plus 1 also. In that case, if this is true, we will simply push back the value for result dot pushback uh, result dot pushback what we will push back I value. Okay, value of I because yeah, because we don't have to return the value, just we have to return the index in the array. After that, when we will push back, we will simply return in the end the vector that we have created. If it will be empty, we will return the empty vector. If there will be value like index is present in that, then it will show in the result. If there will be any peak value present in the solution. Yeah, I already represents the index of what we have pushed back in the result vector. It's showing compile error because of this. Something is missing. Let's see. Current index is more than this, and num size more than this also. In that case, we will push back the result value of nums right at that index. What happened? No, it should be high, right? Let me just see if it was value or what. 1 and 3. Yeah, it should be the index. If we see the solution, we are also passing the I. Oh, okay. Here it should be less than or equals to. Mm, yeah, I think because of that, it was giving that. Yeah, because already we have used less than, right? Because of that, it should be this. Because in this case, when we will do I is less than num size minus 2, then in that case, we will not like even check for the second last value, right? In that case, it will also be excluded, and we will only go till this value, from this to this value only. So we also have to use equals to sign so that it will check for the second last value also. Again, what's the error? No matching function. Oh, here we have missing the I. It was very easy problem, just a disturbance in came between. Because of the disturbance, we forget where we were in between just of the disturbance. It is very easy level problem. Just we use a for loop in this. Okay, to traverse the array from the second value till the second last value, because we have to exclude the very first value and the very last value. Because here if we see the very first value, then we can compare it with the right side element, but we can't compare it with the left side element because there is no left side element present here, and we will try to like check for that value which is not present in the array, which is not, we are like trying to access that value which is not present in the array. So it will give segmentation fault, and this is the same case for this last value also, because we will be able to compare it with the left side value, but there is no right side value with which we can compare it with. Time complexity of this code will be big of n, and also space complexity of this code will be big of n. And you have to just ignore the disturbance, just you have to keep learning. And disturbance will come in between the things, but you just have to follow the things that you are following. So okay, I will mark it as released it. It was supposed to be finished in just 10 minutes, but because of the disturbance, it took more than plus more 5 minutes because of that. Just because of the disturbance. Now we'll take a 2 minutes break and we will go jump on to the next problem, or maybe in between I think I should see some problems. Because these won't be easy. Just this is the find peak element. We have to find peak element. We will use binary search in that, and and here this is the candy problem. Here we will have to assign candies to the children. So yeah, let me just see the list of the problems. Like I have already in mind which problem I have to solve, the very first problem, but that should be a second problem also. I think, yeah. And today I was thinking to pick this problem, like search in a 2D matrix, which we saw yesterday. But I was thinking about it like how we will access the values of these things. Just there will be a target given. We will have to use binary search in that. And it is like a matrix. Like in matrix, the values are already in increasing manner. We have to find target in this, right? Maybe using binary search, we have to check for in which array we have to go. Sorry, no, these are not array, right? These are list of vectors. So you have to check like in which vector we have to go. We will see that there will be some new things that we will have to learn from here in this. Like I have seen that there will be rows and columns which we will learn about. 1, 3, 5, 7. Okay, we will see it in between the things. So the second problem that I will revisit is find peak element, in which binary search will be used. Like here you will see a combination of like 3 different type of problems. In this we used linear search. In this we will use binary search, and in this we will use greedy algorithm to solve the problem. Like in greedy algorithm, we try to get to the solution as fast as possible. Right. So yeah, it will be find peak element. In this, what we will in this problem we have to find peak element, but this is not like type of mountain peak index that we are trying to find, because in this peak element can be on present on n index. Okay, maybe it is present on the very first index or very last index. We just have to return one value which is like the peak, okay, which is behaving like the peak. If we read the problem here, it is given as a peak element is an element that is strictly greater than its neighbor. Okay, whoever their neighbors are. Here we are given a 0 index integer array nums. We have to find a peak element and return its index. Okay, we just have to return the index of it when we find a peak element. If the array contains multiple peaks, return the index to any of the peaks. So I think you got the point. Maybe the array contains more than one peak, but we only have to return only one index of any peak, any given peak value. You may also imagine that nums minus 1 is equals to nums n is equals to minus infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. What does that mean? Means if we check for it and compare it with the right side, it will be the neighbor. But if we even not compare it, like with this value, then it will already be considered that it is greater than the value which is not present in the array in this side, and that's why we will use these conditions to naturally check for that cases. Okay, these conditions will be used in natural cases in which maybe we are the mid is on the this value, the very first or very last, right? And for that first, yeah. So I will remove this all the code, and first we will create a vector that's sorry, not a variable in which just the number of elements present in the nums array will be given. And after that we will use two if conditions, that if nums 0 index, okay, is more than nums first index, then in that case we will return 0 because it will be the index, okay, of it. What we are checking, if this index value is more than this, then we will return that as a peak index, and finally end the code. But and there is another condition, if maybe nums last value means n minus 1 is more than nums n minus 2 means the second last value, okay, means the previous value of it, then in that case we can also return what we can return n minus 1 index, okay, like the last index. Just wait a second. First n minus 1, right? Yeah, we have to return n minus 1. I was just cross checking that, maybe because I was thinking maybe something else will be returned, but it was nums n minus 1 means the current index on which we are. And if even these two cases are not true in the natural form, then we will use, now we will apply binary search on the whole array. How? So we will create two variables. One is starting from the very first index, not the very first. It will start from the second value, and another variable and name as, it will start from nums. Sorry, it will start from second last value. And after that, we will use a while loop in which we will go till start is less than or equals to end. Okay. Then we will check if nums mid, right? If it's sorry, if nums mid minus 1 is less than nums mid value and nums mid is more than nums mid plus 1 means it is more than, like, bigger than both the neighbors, and both the neighbors are smaller than the value of the mid, then in that case we can return a mid index, fine. And in the there will be two else if cases. Else if nums mid minus 1 is more than nums nums mid, in that case we will check for it in the left side of the array, means n will become mid minus 1, okay. And else if maybe nums mid plus 1 value is more than nums mid, then in that case we can check for the value in the right side, right side of the array. Mid plus 1 means right side of the array. Fine. And maybe even after traversing the whole array, we not find any peak element. Okay. So in that case, we can return -1 as we not found any value, peak value. So yeah, here we will return it. After the loop, instead of -1, we can also return start like it is guaranteed that it will be found. Okay, it is not guaranteed, right? So yeah, we can return -1. First, let's see compile error. Okay, just because of the semicolon placing at the wrong place. Oh, again compiler expected this. Okay, here. How it changed, man? Like I even have not changed it. And here this bracket is missing. Undeclared. Oh yeah. We forget to like calculate the mid, man. The main thing. It's the start of the binary search, right? Mid is equals to start plus end minus start divided by 2. It's subtracted. So add the what? Overflow? Where, man? Where it's showing overflow? But how is it possible? Like even here, we have check this. See, num0 is nums more than nums1. How can in the revisit it's giving this error? Maybe we should ask for it. Why it's giving error in the permission as overflow. Oh, edge cases. Analyzing size, array size check missing. If nums then tries to access nums1 or nums2 and -2, which doesn't exist segmentation for. Way, man. Int and nums sizes this. Mm, oh yeah, we also have to check for if only one value present in the array, right? If nums dot size is equal to 1, then we will return the 0. Like it will be only, there will be only one index, that is 0. Right. So base case is done, this case is done. Return n minus 1. Start and while this mid, this is correct. Else if mid, okay. Maybe because of this case it was, oh, okay, here is the something is wrong. I think because of the base case it was giving false. If I submit it, then before submitting it, let's check. Like let's take a look on this code. Yeah, I think things are similar. And for safety, we can return start because it is saying that it will, there's a guarantee that there will be a peak element, right? So gets accepted. So what we have to find in this, just we have to find where, like, we have to find any peak element present in the array. Okay. And peak can be on any index of the array. Like even the very first or very last. Like we are not finding the maximum peak number, okay? We are finding any peak element which is present in the array. And peak element is defined by the value which is more than its neighbor. Okay. If there is only one value present in the array, then we can return that value as like 0 index. If 0th index value is more than first index, that means right side of the array value, then in that case we can return the 0th index. If the last index value is more than the second last index value, then we can return last index, not the value of it, because we have to return indexes in this problem. Here we have used only one simple binary search, okay, but from the second value till the second last value we are going. While start is less than equals to end, maybe because at any point maybe start and end becomes like have to come at one point, single point, and there will be only one value left. After like reducing the search space again and again, maybe we will eventually reach that position where only one element will be present in the array to check for. Fine. Here we are checking the three conditions. If mid value is more than the previous and also the next value, then it will be a peak value, so we can simply return it. If not, in the else if case, if mid minus 1 is more than mid, like the current value, then that case we can search for the peak value in the left side of the array, okay? Because mid minus 1 is the left side of the array. And in the else if case, maybe mid plus 1 is more than mid, means mid plus 1 is in the right side of the array. So we can check for it in the right side of the array. And every time we are calculating mid, so we will also compare mid with, like if mid is this, so we can simply return mid. If there will be any peak value we will find, then we can return it. Or if we not find any peak value, we can return this, like start just as, but it's said that there will be a peak value be present in the array. And if only one element, then we can return this. If the very first is more than second, then we can return the index of very first. And if very last is more than second last, then we can return very last index. This is how the code is working. Just simple binary search and some natural check cases in which only one element is present, or very first index value is more than second index value, or very last index value is more than the second last index value. Just there are three base case checks. After that, we applied binary search on the array. When we applied binary search, inside that we traverse the like we check for the values between the like second value till the second last value, excluding the very first and very last value. And to check for very first and very last, we already used these conditions before applying the binary search algorithm. Okay. What happened to this man? Description code. Okay. Test result. Okay, this should be like this. Okay, now it's fine. Okay. So this was the code for this problem, and it was a medium level problem. Time complexity of this code will be equals to log n, because we did just use simple for loop like loops and used binary search in that. White peak element. Second revisit is done in very less amount of time. Name was find peak element. And problem find peak element. No, not this. This was the problem. Find peak element. So now the 5 minutes break will start. Okay. And till the break end, you all see the problem. Okay. You all see the problem and try to understand the code like what I have written this. And yeah, till the break ends, you all see this. I will come when the break ends and we will revisit the third problem of today. After that, we will solve new problems. That will be a fun. And maybe that a revisit of the first two problems was not that good because there was some good amount of disturbance coming in between. So because of that, okay, I think you all understand, got me. But the third problem that we will revisit will be in a good way, and also the new problems that we will try. They will also be in a very good flow. So yeah, till the break ends, you all see the code and try to understand what's written in the code. Hello, hello, hello. Hello, man. Welcome to the stream. Hello, hello. Yeah, I was just in the break time. Are you able to see those messages like which I send in the chat? Just the break was going on, and like I'm on a washroom break, so yeah, I've done the revisit of two problems already. Just was going to do the revisit of the third one. Then after that was going to solve new problems today based on binary search. And yeah, in between, like I also like breaking the roadmap a little bit because we don't have to give so much time to binary search because soon strings are going to start. So I was thinking to like solve a good amount of problems based on binary search in a less amount of time. Because men have also not solved so many problems using binary search, so I will be following that till the strings start because it's starting very soon, I think. There are not so many lectures in between. What about you? Hey man, I saw your post on LinkedIn. I think my voice is not coming in a good way. Nothing, I think it will be fine. Assign cookie. How you felt after solving that problem? Yeah. Now I think the voice is coming in a good way. A little bit. So this problem name is Candy, okay? What we have to do in this, there will be n children standing in each line, in a line, like this. There will be n children standing in a line, and each child is assigned a rating value. Like these are the rating values we can see here. The rating value of first child is 1, second is 0, and third child is 2. In the integer array ratings, okay, the name of the array is ratings. You are giving candies to the children subjected to the following requirements. What are the requirements? Each child must have at least one candy. Okay, each child will must have at least one candy. Okay, children with a higher rating get more candies than its neighbors. Okay, we have to return the minimum number of candies. We will need to have to distribute the candies to the children. Like if we take this example where there were three children, we can clearly see, and if we check for the very first, like all the children will by default get one candies, okay, at least. So when we will compare the very first children with the second children, which value is like 0, rating is 0, so that means this children has more rating than its neighbor. So we will increase the number of candies he will get. So in that case, the very first child will get two candies, and when we will check the last child with the yeah left side child rating, then it is also more than the right side child rating. So in that case, yeah, so in that case, we will also increase the number of candies he will get, right? And for that, I did write this code. Like yesterday, we understood it with the help of AI. Like the logic was in my mind that there will be value compared, the neighbors will be compared, right? And we will increase the value according to that. If current children rating is more than its neighbor. So for that, I created a variable which shows the number of elements present in the ratings. Yeah, present in the ratings array. After that, I created an empty vector inside that, in which we will store the value, updated values of which we will give to the children's. Okay. So what I did first, I first gave it the size of the ratings, like the number of children present in that, and also initialized all the values with 1 as default. Means all the childrens by default will get one candy at least. Okay. Then after that, I ran a loop from the left side to the right side, going from the very sorry, yeah, first second value till the last value. Okay, and comparing the current element with the element left from it. Okay, means the previous element, comparing current element with previous element. What I have written here, you can see, if a rating index value is more than rating I minus 1, means if this index value is more than this previous value, then in the candies index, like current index of candy array, okay, we will update the value of it by is equals to I minus 1 plus 1, right? Mm, mm, mm. And the difference for the right to left, like in the right to left, we are traversing the array from yeah, second last index to the very first index. Okay, like we are comparing the value, second last value, uh, with the value next from it. Okay, like this. We all know children must have at least one candy. So this straight candy is equals to and then just candy plus plus. If you have high rating, what do you think about it? What? So just write if it have high rating, what do you think about it? Yeah, for checking the high rating, I have like used this, right? Like comparing it with the neighbors. And also we have to do it separately because maybe the values can be updated in a wrong way, like from this to this part. It was already accepted. I'm just doing the revisit of the problem. You know, it's already accepted yesterday. And in this case, we are checking from yeah, for the right value, comparing it. Yeah, for the left value, comparing like the current value, we are comparing it for from the next value from it. And if it's that's true, if it's more than the next value from it, candy candy's index will be equals to maximum of candy's index and candy's index I plus 1. Okay. And then we simply ran a like created a candy sum variable and we ran a for loop to calculate the sum of all the candies like which all the children get, and in the and we return the candy some value. Okay, sum of all the candies that all children got. If I try to show you in the yeah, I think here I done it. Mm, because maybe in the left side check, in the left side check, maybe its rating will be not more than its neighbor, but maybe in the right side, when we compare the right side of it with the current index, maybe it is more than the right side. So we are also using checking for that case also, right? And maximum, we are using maximum because of, if I show you here, like maximum we are using is it as a safety net. It prevents a child from getting less than required. Okay, because we are like given to check for its neighbors. It also prevents a child from getting more than required unnecessarily because we only keep the larger of the two valid values. Okay, like the value which will be larger, we keep only that value in the result array, like candies, which the children will get. Hmm. And yeah, the right to left loop is running in a backwards way. So first we will create a variable named as not num size, right? Ratings dot size. Because the size of name of the array is ratings. Then after that, we have to create an empty vector named as candies. Not yeah, we will name it as candies vector. Type is integer, and we will name it as candies. Then after that, yeah, we also have to give it the size of the vector of ratings. Oh man, why this things of type of things happen? And we will also initialize all the values of candies with one because by default we have to give all children at least one candy, right? And after that, yeah, why I use this then? This will be not needed here. After that, we will run a for loop, right? From left to right. Left to right. Inside that, we will go from the second value to till the last value, right? Plus plus. And inside this, we will check if current index value is more than previous index. So if rating index is more than rating index minus 1 means the left side of it. So in that case, candy candy's index value is equals to candy index value plus 1, right? But it was said that candy is I minus 1 plus 1, right? Then after that, we have checked for the left to right. Then after that, we have to check for right to left. And what's happening in the left to right, if I show you? Uh, okay, we can take this array, right? Not this. Okay, we can use this example. Mm, mm, mm. example array was given 1 to 3. Okay, where the ratings of students are like follows. When we check for the first, when we on the first iteration of it will be on this index, and when we compare 2 with 1, it will be more. So the number of candies that children will get will be 2. Okay, and when we will compare 3 with 2, it is more than 2. So it will be 3. The number of candies in that case will be 3, right? Like what? What we did here is 2 was more than 1, right? So candies current index uh, value plus 1 and plus 1, right? It will be updated by one value, but just we wrote candy index, current index values minus one value plus one value. Okay, means one value more than that. If the neighbor value is more than that. So if I copy, we can copy this loop also and just change some conditions that it will start from the second last and will go till the first index, and it will run in a backward format, and it will be rating index is more than rating index plus 1, means the current index value is more than the next index value, means the right index value. If this is true, say then candy's index is equals to candy's index I plus 1 plus 1. It means one value more than which is present in the candy's index value, which is present in the index value of candies, not the current one, like the next one of it, and plus 1 in that, and that will be the current index value of candies, new current index value of it. But here it will be max, right? Candies index value is equals to max of candies I plus 1 and candies index, right? Comma candies index. And after that, this for loop, we can create a variable like named as candy is start from 0. We will use a for, okay, we can use a for each loop named as integer k can, and it will run for this. And after this, inside this, we will like calculate the sum candy will be equals to candy plus equals to all the values present in the candy array. Here you forget to use the, then in the end we can return candy. Okay, instead of candy we can name it as candy sum because it will be a sum of all the candies, right? Right to left, white is just came here, man. uh, Compiler is coming. Okay, this was the compiler, no? I even have to finish the evening lunch, man. Just because of that, I'm doing it in a. Oh, okay. Ratings. The name of the array is ratings. Again, we forget to write the name as like correct name. Just it will be ratings instead of a rating. Ratings. Candies. It's passing one test case and failing the other. Output is 4, expected was 5. Okay. There is some mistake in. Let's like get a glance at the code that we provide before. Candies index is max. Candies index I plus 1, right? Candy. Oh, wait. There's something wrong in. I is less than candies dot size, right? It's accepted. I will submit it, and time complexity of the code of this problem was equals to what? It was equals to log n, right? It was equals to log n, right? But space complexity will be log n because we also created another vector. So why not it's given, man? Give me the time complexity. Yeah, it is equals to big of n. Space complexity is also big of n. Okay, let me show you the dry run of the problem in a good way. Give me a simple and short dry run of the problem using the values only, and in which both right and left check will be used. Okay. Take 132 as ratings. First we initialized candies, all like give all the children one candies as default. Then we check like in the step 2 we run this for loop like for left to right. In this, the second value was 3. Okay, when we compare it with the very first value, it was 1. So it is more than the value like the first value. So candy's 1th index is equals to candy 0th index plus 1 means 2. Like this index value plus 1, so it will be 2. Here it has become 2. When we will check for the third value of ratings, it is given 2 here, right? And yeah, it doesn't matter if it's like it's 3 more than 1, just it should be like more than the neighbor. Okay, then that case we will only increase 1 candy, not if 3 is more than 1, then we will increase 2 more candies and it will be 3. So that will not behave like that. Then we will check for the third value. Then 2 is not more than 3, so no change. So it will be like this 1, 2, and 1. When we will check for the step 3 in the right to left, we compare right value with left value. No, we compare a left value with right value, right? So when I will be on its first iteration, means ratings second index value, right? Second last index value, because this is the second last value. It will be on second last value and is more than 2, right? 3 will be more than the 2. When we compare 3 with 2, it will be more than 2. In that case, candy's second index value like this will be maximum of 2. Okay, which is already present, and which is already in the candy array, and candies 2 plus 1 means, yeah, it is also equals to 2. Like candies, this index, the next index, the right side index plus 1 means 2. So it will be 2. The maximum of both of these is 2. So it is not changed, just it will be 2. And when you check for the very first index, that value is 1, right? Yeah, it is 1. When we compare it with the second value, that is 3, it will not be bigger than that, so no change. And in the end, we get 1 to 1. Oh, like here we get 1 to 1, right? Then we will compare the very first index value with the second index value, then it is not more than that. And in the end we get this, and after that we do the sum of all the values present in the candies array, and it will be equals to 1 plus 2 plus 1 is equals to 4. So what Max is doing, left pass gives child with 3 more candies with rating, left pass gives child with rating 3 more candies than its left neighbor. Right pass check the same child against its neighbor, ensuring it's also greater there. Okay. Max keep the correct value without reducing it. The final candies was this. And what Max is doing, Max is just checking the maximum value which we get, which we should pass, so that it will be the current amount of candies will be given to the children. Like here also we get 1, 2 and 1. Sorry, 2, 1 and 2, 2, 1 and 2. And you can clearly see it was more than its neighbor, so it got 2 candies. It was not more than its neighbor, so it got only 1 candies. And it was more than its neighbor, then it also got 2 candies. The just those values, just those number of candies which will be required, right? Like not more than the required more candies, and also not less than the required more candies. Just the right amount of candies that the in which it should be given to the children. So okay, third problem revisited today. Not today, man. Third problem revisited name was Candy. Just the name of the problem is short, but yeah, it is marked as hard. But that isn't a very big thing, right? Just as a marked as hard. So now I will take a 5 minutes of break in between, and in between the break I will try to finish the lunch. 5 minutes of break started. Okay, and in the break time you all can try to see and understand the code, like what is happening in this code. Okay. I will be here just finishing the lunch. Don't know, maybe it will be visible or not. Just yeah, just these are the things. Just I will finish that. Then after that, we will start the new problem of today. And in the break time, I will be keeping my turning off my mic till the break ends. Hello, hello, hello. Hello, hello, hello. Hello. So, man, today's us. Yes. Hello, 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 hello. Yes. Hello. So the new problem that we will revisit is like, okay, first I will end the break. Don't know how many viewers see this that I ended a break or started a break or like finished a problem or revisit a problem. Yeah, just woo. Hmm. So this problem name is single element in a sorted array, in which like which is pending from I think is from the last today. I have already understood it. Today I also understood it. So what we have to do in this, we have to there will be an array given. Where will be a there where will be only one value which will be unique and all the other values will have a duplicate of it. Like here, the first value one is one came twice, just two came once, and after that again three came twice, four came twice, and eight came twice. Mm, okay, so let me read the statement. You are given a sorted array consisting of only integers where every element appears twice. Okay, except for one element which appears exactly once. We have to return the single element that appears only once. In this case, we will have to return the element, not the index. And we must run a solution run our solution must run in login time and space complexity. Okay, so for that we will have to use a binary search in that. So first I will write the code, after that I will explain the code, like what is happening exactly in the code. So integers start equals to, we will start from the zeroth index and will be yeah, nums size -1. Okay. Then after that, I will use a while loop. Like first, we will do the steps what we do in binary search. Start is less than equals to by end. Then after that, what we do? Yeah. First, there will be a base condition also, which we can check for like, and there will be also some conditions at the starting point also. First, I will create a variable int n is equals to nums dot size. Okay. Here it will be nums. We can name it as n minus 1 also. Okay. Here we will check for two conditions first before starting. Like suppose nums zero index value is more than nums one index value. Okay. because single element can be present on the very first or a very last index also. So okay. The nums1 index, if it's more than nums1 index, then we can return that index. Okay. And if uh, nums last index value is more than nums second last index value. Okay. And then in that case we will return last index value. Okay. Nums I minus 1, right? Nums n minus 1, and here it will be nums 0, right? Because we have to return the value, not the. Okay. And yeah, there will be some duplicates also, so that's why I have not used that condition in which there will be only one element present in the array. So after that, what we do in the binary search, we first calculate the mid. Mid is equals to start plus n minus start divided by 2, right? And then after that, what we will do, like when we will get the middle of the array, like in this case, there will be some duplicate values, okay, and there will be only one element that will be unique. So if we check for this, the array size will already be array will already be a odd array, okay. The number of elements present in the array will be odd, right? Like if we check for this 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 elements, and it's a odd array. And middle value will be at the fourth index, right? 0, 1, 2, 3, 4. This value will be the middle value. Okay. So if middle value, what we will check if first we will check if middle value is odd or middle value is even. Okay. If it will be, okay, let me show you. If mid is equals to, if mid modulo bit 2 is equals to is not equals to, if it's not equals to 0, okay, means that it an odd array, right? Like we have to check, it means the such space will be an even space, right? Wait. Okay, it will be equals to 0. Then it means mid is at the even index, and other values of it is like even. See, it is at the even index, like 0, 1, 2, 0, 1, 2, 3, and 4. So it is on the 4th index, right? And 4th is an even index. And when we check for the other values, like left side and right side, so you can see all the values are in even, like all the values are even. The number of values are even here and here also. Okay. And then the number of elements will be like this. Suppose this is also an odd size array, but when we will calculate the mid will come at this point. Okay. Then we will check if mid is odd or even. Then mid will be odd in this case, because mid is at 0, 1, 2, and third index. Okay, so third index is, when we will divide it by 2, it will be a odd index. And now how we will check for left and right, when mid will be even. Okay, when there will be even values present in that. So inside this there will be two conditions used. If mid I minus 1, okay, means left side value of mid, sorry, this is mid. If left side value of mid, if it's equals to num, sorry, not mid, okay, here it will be nums mid. not I, it will be mid, right? Yeah, mid -1. It is nums array, and it will be nums mid. That means that okay, this value is got like when we compare it with the left side of it, the left side value is also the same as the current value. Means when we'll do it, see here there only be three elements present here, okay, and it is a sorted array. So when there will be three values, there can't be any possible pair like. Then we will definitely get to know, okay, there will be three values, so two values will be a duplicate, but the third value will be in that case will not be a duplicate, right? Because there will be only three values left when we will compare mid with the left side value. Okay, so in that case we have to go in the left side of the array, so and will become and will also become mid -1. And suppose if this is not true, then the this value will be, maybe this value will be equals to the next value of it, means the value which will be present in the right side of the array. Okay, like it will be else case the value should have to be present in the other side, because if it not also present in the other side, oh yeah, we forget to use that condition also. Like here, uh, if nums mid -1, okay, is less than nums, sorry, is not equals to nums mid and nums mid is also not equals to mid +1. Okay, this will be the base case, like in which if this is not correct, then we will return nums mid value. Okay, don't know why the stream is buffering a lot. So this will be the base case. So if this is not true, like maybe in the first middle value we get, maybe it will be the value which is unique, but maybe this is not true. So we are using two different conditions. Okay, this will go in the left, okay, left side, and if in the else case we will go in the right side. Okay, if this is not true, in that case just the start is equals to mid +1. Okay, means right side, it will be found in the right side. Okay, and if I copy this, like there will be a else case of this if condition. Okay, and it will be outside the if condition, that will be the else case of this condition when mid value is not even. Okay, it will be odd value. Then in that case, if again, but the things will be opposite now in this. If it will be an odd array, suppose this, like when after getting the mid, if mid is odd, then the number of elements, the search space will also be, there will be odd values present in the search space. So in this case, when we will compare, okay, suppose here nums mid -1, okay, nums mid -1 is equals to nums mid. So in that case, we will go in the right side. Okay, why? Why we have done that? Let me show you, because here when we will see 7 is equals to 7 here, like the current value is equals to the previous value, and after that there will be only two values left, and those two values will be a duplicate for sure. Okay, that's why we are going in the right side to check for the value, the unique value. And suppose this is not true, then and for the right side we have to start with mid +1. Okay, And in the else case, suppose this is not true, then it will be present in the right side of the, sorry, left side of the index. Means end is equals to mid minus 1. Okay. And there is, it is guaranteed that there will be a unique value present in the array. Like, first let me try to run the code. There will be some errors, we know. Oh, compiler error came at the very first. I think just because of this. Instead of blocks, we use this brackets. Here, let me just see through the code. Yeah, here it will be else case will be left side, right? So it will, we will go in the left side. Non-void function. Void. Close this. While loop here, if condition closed here, if this closed here, else if this closed here, else condition closed here. While loop closed here, function closed here. But before while loop it is saying, what if I return -1? Okay. It was not needed, but because it was said that there will be a unique value, okay. But even after that, we use this because if we not use that, the compiler will give an error. Fine. Oh, runtime error, man. Overflow. Okay, overflow is also coming in that problem, right? Which we did find peak element. It was also the same. Mm. But now I will again ask it why this is happening in the single element in sorted array, right? Why it's giving overflow. Mm. Single element in sorted array, single element in a sorted array. Index out of bound cases. At boundaries you directly check. Oh, yeah. Oh, yeah, sure. Start will not start from the zeroth, right? It will start from the second value so that we can compare these. I was thinking about that because we already checked for the other base cases, right? Not accepted. I think if I submit it, it will be accepted. Just let's see. So we will not add the base case, man. Why the base cases will even be needed in this? It's not needed. If I check, oh, num's length can be equals to less than or equals to 1, or what about now? Oh, why? But why when n will be mid like 1 minute? Mid minus 1 pay, but n. Okay. Oh yeah, we also have to exclude that value. Like the very last, okay, because we also check for the very last. Uh, the style of writing code of he is was it is a little bit different. Yeah, but it was not giving. Okay, let's see in the. mm, okay, the condition was a little bit different. And according to this, there can be a single element also in the array. Hmm. Okay, this should be put after the calculating the mid, right? If nums mid, wait, if mid zero, if mid is equals to zero and then okay, zero index, and and array zero index is not equals to array first index. Okay, means the current value is not equals to the first index, right? Then we return the mid array mid value. If mid index is equals to zero, and nums zeroth index value is not equals to nums one, in that case we have to return nums mid value at that index, right? And if it in case, if this is the case, oh, mid is equals to n minus 1. Yeah. If mid is equals to n minus 1 and add nums n minus 1 is more than nums n minus 2. In that case, we will return nums mid. Sorry, yeah, mid. Unsigned offset. No, not more than when. If it's not equals to Send overflow line 34. Scale vector. Major bug. Okay, yeah. It will be equals to equals. We are checking if it's equals to right. Again, it gives the wrong. I think we have submitted it 3 times, right? Oh man, because of the hidden test cases, I think we have acceleration and -1 to mid. And a condition becomes true always, not zero. That's why. Okay. Corrected code is this. Why this code is looking very similar, smaller. Oh, skip this pair. Single lies on the left side. Start is less than. Even why we are seeing that code? Why not see the code of the what ma'am wrote in the code, right? Uh, Instead of this n-1, means the loss, but in mid is equal to start to plus and divide. Okay. And now we are already checking for the. It was not supposed to be like this. Like I understood the problem, but mistakes initialization of column start one and end with what later you access mid plus one. If mid is elements one, then elements mid. Correct. And should be elements two, but how man? Boundary check. Problem you never allow mid to become zero because start. Oh, boundary check for mid minus 1, problem same issue. So this check is dangerous unless you fix problem same issue. Okay, it's problem with your current and minus 1, but then later you access mid plus 1, which is invalid. So this check is dangerous unless you fix and is equals to n minus 2. Okay. Neighbor checks. Oh yeah, not n minus 2, it will be n minus 1, right? I think ma'am has also start with 0. Right, so that the very first and very last value can also be checked. Needs boundary guards. Neighbor check with boundaries. The problem is mid is equals 1, comma nums mid minus 1 is fine. If mid n minus 1, comma mid plus 1, what? Nums mid plus 1. Determines. Problem it could guarantees there is also not only minus 1 is unnecessary and may cause wrong answer. But it was not getting accepted. See, compile error. Let's see. It was supposed to be just solved in our first turn. It was supposed to be just solved in first, but it didn't happen. I think. Okay, we got runtime error 2 times, and after that wrong answer. Maybe because I was just trying to solve it like in a faster way. I was trying to become fast. Time complexity of the code that we have written is equals to big of log n, because just we did use binary search, right? I have already told you like what is happening here and how we are checking. If middle value is odd, then middle value is even, then it will be an even array. Like the search space will also be even values present in that. And here we are checking where, okay, this, if this is even, okay, then the values present in the left or right side will be even. If nums mid minus 1 is equals to nums mid, okay, means if current index value is equals to the previous index value, means in that case, if we check for it, okay, this is correct. So, and after that, there will be only 3 elements left in the array, okay, in that side of the array, left side. So if 3 elements will be left, it is guaranteed that the unique element be present here there, because it is already matched the value with the previous element, and there is only 3 elements left there, and there can be only 2 duplicate values, right? And so that's how we got to know that, okay, the unique value present in that side of the array. And suppose if this is not true, so they will be present on the other side of the array, and when we will check for it in the right side. If this is not true, then else in the else case we will go in the right side, and in the else case, if maybe mid is not mid is odd, okay, mid is an odd index, then in that case we are checking if nums mid is equals to nums mid minus 1, means if this value is equals to the previous value, okay, right? Yeah, again, but if this is true, then we will go in the opposite side of the array, means we will go in the left side of the array, not right. Okay, yeah, right side of the array. Means if this is true, suppose this is true, then when it will be odd, there will be only 2 value left to check for, and we already know that if there will be 2 value and the array is already sorted, then those 2 values will be even. No, will be duplicate also. Okay. So we'll try to check it for in the right side of the array. That's why we have started with mid plus 1, means right side. And in this case, suppose if this value is not equals to the previous value, then that case it will be equals to this value, okay, the next value. So that we will check for it in the left side. And we already did some like base check, base cases check, in which first we check if suppose the very first index value, okay, the very first index value is not equals to the next index value, then that case it will be a unique element, right? So we can return the index value of that directly. And if mid is equals to the last index and last index value is not equals to last index value compared with the second last value, okay, means the previous value of it, then it will be also be a unique element, right? Like if we check for the very first, suppose 3 is not equals to the next value, okay, there is 3 and 4. So we can return the value 3, okay, which is present on the very first index. And suppose the very last index value is not equals to the second last index value, means here suppose it's given 11, but the next value like the previous value is 15. So if we compare 11 with 15, it will not be equals to 15. So we can simply return the value of that index, that will be equals to 11. And here we are checking if suppose we calculate the mid for the first time, it will be the middle value. And maybe when we compare it with its neighbor, mean the left side and right side, okay, both the side, if it's not equals to both the sides, means 3 is not equals to the previous value or the next value, then we can directly return the middle value as the unique element. In maybe in the good case we find get to that. That's how the code is running. So now we will take a 5 minutes of break again, I think. Okay, let's see time complexity of this. Yeah, it was equals to log n. Hmm. So I will copy it and just mark it as solved. First new problem solved. Name was this single element in a sorted array. Right now, 5 minutes. A break started again. Fine. After the break, we will try another new problem. Like because the according to the roadmap, we have done the things that we are supposed to do today, but we also have to do like a good number of binary search questions. So because of that, I will pick some more new problems today. Fine. Oh man, I don't know why I'm just using some wrong words. I just wait. I will be back till the break ends. You all try to see and understand the code. The code is a little bit longer. Don't know how I will be able to show the other part of the code. Okay, till the break ends. When the break will end, I will show the other part of the code also. Till then, you all can first try to understand the first given part, which is visible in the on the screen. Hello, hello. What's the other part of the code? If anyone was seeing this, hello, hello, hello. So I think the second problem that we should do today first is, oh, wait, man, wait. Where it's showing that 52, but here it's showing 54. Okay, we forget to add the candy problem here and also the new problem that we did. Where is that? Where is that? Okay, why not search it? Candy, candy, candy. It's in favorite list now. Now we will have to add the problem that we did today, right? Where it is being saved, man? I think it's being saved in the favorite list. Oh, it's not showing here. It could have its own problems. Come on, come on, come on, come on. Okay. So now I think the second problem that we should do today is, that problem that I saw yesterday, in which there was rows and columns, right? That's in a 2D matrix. I was thinking to do that, but let me just check for another problem also. Oh yeah, break is ended. Starting position. We can also try to solve this problem also. Just there will be a target given and we have to check the starting and ending position of the target. We have to return those positions as indexes. And this binary search will be used. Uh, uh, yeah, it's not that just not that just that hard, right? We can use for base cases and the middle values and check for it. If it is this, then we can return those indexes, right? In a new array. So we'll see that. First, I wanted to solve this problem, and there is also a part two of this problem. Okay, and there are also some problems being left to solve, man. I think there is a Windows update has came, so because of that, it is getting slowed a little bit. I think we should not disturb it. Maybe check. Okay, I will delete this. We should also delete this, right? It's been here for from a very long time. Now I will create a new chat and ask for this problem. Oh, sorry. Search in our 2D matrix, right? tell me what we have to do in this problem. I know about array, vectors, and binary search, right? I think we know a little about binary search. Got it. Let's break the step. So you are crystal clear on what's happening in a search in a 2D matrix type problem. Okay. So problem setup is like this. You are usually given a matrix, two dimensional array. Each row is sorted left to right. Okay. Each column is sorted top to bottom. Column, 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 rows, rows, and rows. A target value you need to check if it exists in the matrix, right? Like here, matrix is like this. Okay, three, four. First column, second column, third column, fourth column. First value of the row, second value, third value, fourth value. First column, second column, third and fourth column. Target is 5. What we have to do, we need to search efficiently, better than brute force. Scanning every element means binary search will be used in this. Brute force basic array vectors, just look through every element. Time, oh, m into n. Not efficient for large matrices, right? Binary search row by row. Since each row is sorted, you can binary search inside each row. Time is equals to m into log n. Oh, optimistic staircase search. Start from top right corner. If current element is more than target, move left. If current element is less than target, move down. Grand staircase search. Zeroth column, third value is equals to 11. What? Um, I haven't done this type of problem before. Okay, let's this first time problem with the problem and go step by step. So understand the matrix rules. Rows are sorted left to right, columns are top to bottom. You need to check if a target exists. Why brute force is bad? Oh man. Okay. Why brute force is bad? If you scan every element, this is too slow. Step 3 is smart staircase. Think of it like standing at the top right of the matrix. If current element is more than target, move left. But how when it okay, top right corner, this corner. We move left, left, left. If current element is less than target, right? Means the rightmost element is less than target, then we will move down. But what will happen in that case? If equal found it, this works because of the sorted property that it gave the code. Rows is equals to matrix size, columns is equals to matrix zero dot size. Okay, Oh, start at top right. Top right. R is 0. C is equals to columns minus 1. Columns is equals to, oh man. Function signature rule. We take the matrix as a 2D vector. Oh, okay. We take the number we want to find in the target. Function returns true if found, else otherwise false. We get dimensions. Rows equals to total number of rows. Matrix size. Oh, columns is equals to total number of columns from first row. This helps us know the boundaries. Starting point. Int row is equals to start at top right corner. Row is 0. Column is equals to last. But it's saying that matrix zeroth index dot size. Then how it's last, man? Columns is equals to total number of columns from first row. Okay, matrix 0 dot size. Why? Start at top right corner. Row is 0. But how row is 0, man? Because from here, if the number is too big, move left, numbers get smaller. If number is too small, move down. Oh, while loop, while row R is less than rows and column is more than or equals to 0. Keep searching as long as you are inside the matrix. Stop if you get out of bounds. Past last row or before first column. Comparison logic. If found equals to return true. If matrix row column is equals to target, okay. Matrix row column is equals to target. If current element is okay, move left, decreases column. Okay. Uh, C minus minus. Okay. So I think column is starting from the last index, right, or something. And S R plus plus move down if it is less than the target. So according to that, end of search return false if loop ends without finding the target, we return false. Okay. Column will rows will be equals to number of elements, right? Total number of rows. Rows is equals to matrix dot size. Okay. Columns is equals to matrix 0. We will try to understand it also why it's written like 0, right? Starting R is 0, columns is equals to, okay, int R is 0, column is equals to n minus 1, or what? Cols minus 1. Okay, means the very last column and very first row. Why initialize calls with matrix 0? What does that mean? Matrix is a 2D vector. Basically, matrix dot side tells you how many rows are there. Look at the first row, matrix 0, and tells you how many elements, columns. Look at the first row, matrix 0. Okay, first row. Okay, and tells you how many elements, columns are inside it. Total columns in first row, total rows, rows, columns. Why first matrix? In a proper matrix, all rows have the same number of columns. Yeah. So checking the first row is enough to know how many columns the whole matrix has. Okay. Example. Rows 0, 1, 2. Columns are 3, 3, 3. Here, matrix dot size equals to 3 rows. Right. First row, second row, third row. First, second, third row. Column are 3, right? First column, second column, third column. So H case was also there. If matrix is empty, then matrix 0 does not exist, it will crash. There, why in real code we often add a check. If matrix is empty, we directly return false. Right? And it was also saying something that why he did give me the code directly. Okay, because this is a classic problem and staircase method is most efficient. Instead of wasting time on brute force, it wanted me to see the clean optimal code first. But since, okay, I'm now walking you through every line, so you just copy paste. Okay, we will see the dry run of it also. But that case is not present here, right? Like in which matrix is empty. So while rows is less than columns and columns is more than 0. More than or equals to the 0th column, right? The very first column. So while row is less than rows and column is more than or equals to column, right? It will go to the last row and go to the very first column, right? Because it's running in a backwards manner here. If matrix row and column is equals to target, okay, there we can pass two values, right? Matrix row and column is equals to target. Then in that case, we have to return true, right? Okay. Else if the current value is less than, right? Else if then so it will be else if, right? Else if matrix row column is what? If this value is less than target, then we will move left, right? If less than target, then in that case row minus minus, right? Like we will check for the previous. Oh no, not row minus minus. It will be column. Row column minus minus. But in this case, it's saying row plus plus. It's already on this row. Row plus plus will be this, right? Mm, move left. If this is more than target, but here we are checking for less than target. So instead of it, first we can check if it's more than target. If it's more than target, then target will be present in this row, right? In the second row. So row plus plus. C minus minus move left. else move down. Move down row plus plus. Just wait, I think we will have to understand it. Matrix row value is more than target, right? Yeah, we are already started it from the very last index, not index. So what we will say, what we will name it? Okay, the very last value of the matrix uh, in the first row, right? First row this is, and row plus plus means we have to go on to the next row, right? So in this case, if the last value of the first row is less than target, right? Then in that case we go into the next row. Else if it's more than target, okay, then we can check for column like we can check for the previous columns. Okay. And even in the end we not find the value, we can simply return. Okay, return false. Integer rows, integer column. See, undeclared identifier C. Okay, column. Column. C is less than equals to columns. Rows. C. Return matrix. Oh, not return man. If it will be if condition. Instead of it, we return matrix. Wow. Okay, not it is not name as bro. It is all right. First row, second row, third row. First column, second column, third column, fourth column. Boom. Passing one and failing one test case. Why? Okay, more than not columns, man. It will be zero, right? Or equals to the zeroth column, like the very first column. Fine. Now we will try to understand what is really happening. And how even we like got access to all the values, right? Hey, can you tell me how we got access to like there was a list of vectors, right? Like how we jump from one array to another, and also how we gave two value like row column is equals to target, like how two values pass check together. Let me break down. Just jump beside our 2D vector and why we write things like matrix, a list of rows. Each row itself is a vector. So matrix 0 means the first row, which is itself a vector of ints. Matrix 1 means the second row, and so on. Okay. Example. This was the first vector inside the list of vectors. This was second. This was the third. Right. Here matrix 0 become the first vector. Matrix 1. Okay. Row 1 become row second row. Okay. It is named as row 0. Means the very first row, very second row, and third row. So yes, it's like a list of vectors tracked one after another. Why matrix first index R tells which row you are in. Okay, maybe we are in this row or this or this. Second index C tells which column inside that row. Maybe we are on this column or this column or maybe this column. So matrix R C means go to row. Inside that row, go to a certain column. That gives you the actual element. Example, matrix is 1 or 2. Okay, matrix first row, second column. The row is equals to 1 means 4, 5, 6. Okay, means the second row. 4, 5, 6, right? Yeah, 4, 5, 6. And column second means element 6. Okay, yeah. Column second means the third value, that is 6 is here. So matrix 1 is equals to 6. Why are two values together? When we write if we are checking the element at row and column C, compare it with target. If it's equal, we found it. If not, passing two values together, it's two levels of indexing. First index, pick the row. Second index, pick the column inside that row. So, because there are a list of vector, right? Analogy, think of it like a bookshelf. Which shelf? Okay, row. Which book on that shelf? Okay, column. This book or this book or this book. These are the shelf, different shelves, and these are the books, which is behaving like columns, right? It is like a dictionary. So this is how in the visual representation also we can see this will be the first row, this will be the second, and this will be the third row. Target is 3. So this is the first column, second, third, and fourth column. Okay. And from where oil is here, man? From where this liquid is? From where this liquid is here? Hmm? From where this liquid dropped here? Okay. So the value target was present, 3 was present where? 3 was present at the very first row, second column. Okay. The very first row, second column. Right? Why are you calling me? It's coming on my phone. You should go outside and ask them directly. Oh, okay. So maybe you should end the stream or yeah, I think I should now today. I should first try to like complete these lectures again in a good in a smoother way. Okay, right? And we've already solved this, but the second part of it will be we will solve it by ourselves. Okay, because there is a second part of this problem also. And I think the time complexity of the code of this it is already given as big of n, right? Give me the time complexity Perfect. Like I asked it from ChatGPT, can I do this type of problem? And it said, yeah, you can do this type of problem. Just even need to understand like how rows and column works. Time complexity left decrease column or down. At each step, R increased by 1 or C decreases by 1. So in the worst case, we make rows plus column moves formula. Uh, M rows and columns. So time complexity is equals to big of M plus N. So we can say big of sorry big of N, but we didn't use binary search, right? We didn't use binary search in this, right? But I wanted to solve it using binary search. Let's see what it's maybe. Okay, let's can we say not exactly staircase case. Staircase search, man, why it did that? Did we use no, the staircase method is not binary search. It's a greedy approach that uses the sorted property of rows and columns to eliminate one row, one column at this step. How use binary? Since you want to use binary search, here are two common ways. Each row is sorted and then binary search on every row. Column, okay. Code sketch. Binary row will be applied on this in this way. Column, okay, I think we should. Rows and columns were like this. And for r is equals to 0, r is less than rows, r plus plus. Int, okay. This for loop closed here, right? And here we replaced start and end with L is equals to 0 means L is what? We can do it tomorrow maybe. It was supposed to be used binary search in that, but it is start and I think it is the end of the column, right? Column minus one. While L is less than or equals to H, starting column and end column, right? Int mid is equals to L plus H minus L divided by 2. Okay. If our matrix row mid is equals to target, return true. If else if matrix row mid is more than target, H is equals to mid minus 1. Means if we see here, T minus minus means we are checking from the for the previous value. So H is equals to okay, previous column, right? We are checking for the previous column. Else if L is equals to mid plus 1 means the next row, right? Oh, mid plus 1. So this is the row and this is the column. Can you explain me? and this code m into login, big of m plus n. Okay, we check each row one by one till the last row. Because each row is sorted, we can apply binary search inside it. Binary search setup: left boundary start of row, right boundary end of row. Binary search loop: while L is mid is the middle index between left and right boundary. Okay. Compare middle element. If middle element equals target, found return true. If middle element is greater than target, search left half. If middle element is smaller, search right half. Mid plus one. Because it is in the middle of the matrix. End of search, return false. If finish all rows without finding a target, return false. Yeah. First it will run for the 0th row, right? Then the first row, then second row. Okay. Okay. So integer. Okay, we have to use a for loop. For integer, r is equals to what? 0. Yeah, 0th row. But it will be row, right? Okay. 0th index. And r is less than rows. Like it will check for the last row also. From where this oil is coming, man? Again and again. Again this oil came. From where the oil is coming. R is less than rows, right? And R plus plus, like it will go till the last row, right? Inside this, we will have to, okay, first and last. So what was the name of the variable? Left and, wait. Left boundary, right boundary. Okay. L is equals to, inside the for loop, it is written right here. Okay. Left boundary start from the left boundary, and right boundary is equals to row minus columns minus 1, right? Yeah, it will be columns minus 1 means the last column, and mid is equals to mid integer mid. Yeah. Oh, before no, it will be integer type also, and after that we will use the while loop. While left boundary is less than or equals to right boundary, right? Then inside this we will calculate the mid is equals to int mid. We can name it as mid boundary, right? Mid b. Okay. Instead of just mid is equals to what? Is equals to left boundary plus right right minus left boundary divided by 2. Right. And after that we will use those conditions. If matrix, right? Matrix is name was matrix. Yeah. Row mid, row mid. Okay, mid value. If rows mid in column, if rows mid column, the column which mid is present, if it's equals to target, we have to return, we will return true, right? Else if matrix row mid value is more than, okay, should we use first more than, or less than. Okay, we will use less than. Maybe it's less than target. And then in that case, we will do is the row plus plus, right? Okay. Yeah, because it's mid, right? Row will all increase by its own, so we don't have to increase rows. So instead of that, if it's less than target, then we will check for it in the right side, right? Mid plus one, and else mid minus one, right? Maybe the left side. Fine, just I did the opposite of it, but L is equals to, okay. L is equals to means the left boundary is equals to mid minus one, not L, man. Okay, H. Right boundary is equals to mid minus one, and here left boundary is equals to mid plus one, right? If this is less than target, then we will check. Wait. Left boundary will be this starting. Start is equals to mid plus one. Okay. In that case, okay, we will check for it in the right side of the row. And if it's more than the value, if it's more than the target, we will check for it in the left side of the row. Right. And after that, if we not found the value, even after that, we can return minus one, right? Sorry, we can return false, not minus one. We will fix the code spacing, like the code formatting, and just submit it. Oh, good. It will give error. It will give error. B. 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 Redefinition of R. Where, man? R. L. H. H. L. Redefinition of R. Target is more than R is equals to what? Left. Right. H is equals to, okay. If it's less than target, that means we have to go in the right side, right? Right side will be what? Okay. R is equals to this, and L left side will be mid minus one, right? A redefinition of a where, man? Okay, we have to use another name as H. Okay, I will name it as right boundary. Fine, and it's our left boundary, and right boundary, left boundary, right boundary, right boundary, right boundary. Will it be a right boundary? No? Yeah, right boundary. Now what? Compile error. A declared identifier L. Okay, LB. Mid B. Semicolon missing. Semicolon missing. There were so many syntax error in this little code, right? L. LB. Not L. It will be a left boundary. Come on, man. Come on. We have to end the stream. Oh, something wrong. What's the problem in this code? Just give me the mistakes, wrong row index used. Here you used right boundary as row index, but R B is supposed to be the right boundary of columns. Correct, it should be matrix of R row. What? Wrong update. Okay, it should be R. R is row, but okay. Row, yeah. Will be row. Because we are in the row and columns are already like mid. Wrong updates of boundaries. You set the updates. If element is less than target, you should move right. In a code, you updated right when it should be vice versa. Okay, I was thinking about this again, why I did this. So it will be left boundary and right boundary, right? Made a plus one. Yeah. Variable names confusing. Used LB and RB left for left, but then used RB again as row index. That's inconsistent. Dead logic. If I submit it, come on, turn the radio on. It's Friday night and I won't be long. Gotta till my hair. Do my makeup on. It's Friday night and I won't be long. Come on, do my hair perfect. Okay, we did it using binary search, but with the help of AI. Okay, I will say that. But I've got to know a little about this, how these things are working, right? Just we have a matrix. So time complexity of the code of both, okay, both the codes will give me the time complexity of both the codes. Okay. No man, I am talking about case and binary that we solve the problem with. Just give time complexity. Staircase is this big of m into n. Space is this big of m log n. Complexity. So staircase big of m plus n. Binary search row wise. Big of m log n. Okay. Fine. If I show you, I have also added that problem. That name is search a 2D matrix. Okay, first I will add this to a list. That it is marked as solved. Yeah, we just experiment like I think I saw the code, but it was needed, I think. Just to understand how the things are working, right? And there's a second part of it. So we can also do that also. Okay. Search a 2D matrix. It's also a medium level problem. Okay, we will see tomorrow. 147752558. Okay. Write an efficient algorithm that searches for a value target. Binary search, divide and conquer. Divide and conquer value target in this m into n integer. Integer in each row are sorted in ascending from left to right. Integer in each column are sorted in ascending from top to bottom. What? Okay. 1, 2, 3, 10, 18, 4, 5, 6, 13, 21, 1, 4, 7, 11, 15, 2, 5, 8, 12, 19. Right, but in the first part, it was like 1, 4, 7, 11, 15, and after that, the next row starts from the bigger value than the previous row's last value, right? So we'll see that. So I will now summarize the stream. I think we should now summarize it. It's already been 3 hours. I didn't feel that, man. That it's already been 3 hours. And yeah, today also a lot of disturbances came in between, and because of that, I'm not in that mood to just, I think I should just focus on the next lectures and finish that. And yeah, second problem solved. And yeah, we also got against our roadmap today and solve another problem. That was the second problem, right? And can't I edit it? I will have to remove it. Second new problem solved. Name was this. Search in a 2D matrix. Search a 2D matrix. Okay. So what we did in today's stream, we first revisited the very first problem of today. That name was find the peaks. Its time complexity was equals to big of n because we deduced for loops in that. After that, I revisited the second problem of today. Its name was find peak element. Okay. And its time complexity was equals to log n because we deduced binary search in that. And after that, I solved revisited our third problem of today. Name was candy, and time complexity of that problem was equals to big of n because we deduced for loops in that. And after that, I solved the first new problem of today. That name was single element in a sorted array. Its time complexity was equals to log n because we deduced binary search in that. And after that, I solved the second new problem of today. Going against the roadmap, we solved the second new problem of today. That's name was search a 2D matrix. We solved it using two approaches. First one was named as staircase approach, and in that time complexity was equals to big of big of m plus n. Okay, and in the bunnies and the second approach that we did used in this, time complexity was equals to big of m log n. Okay. So in total, we revisited 3 problems. After that, I solved 2 new problems today. Going against the roadmap, I solved another extra problem, which was the second problem of today. Okay. So the first problem that I revisited was find the peaks. Okay. Its time complexity was equals to big of n. The second problem that I revisited name was find peak element. Its time complexity was equals to log n because of binary search. And a third problem that I revisited name was candy, and its time complexity was equals to big of n. After that, I solved the first new problem of today. Name was single element in a sorted array, and its time complexity was equals to log n because of binary search. After that, I solved the second new problem of today using 2 approaches, and the name of the problem was search a 2D matrix. And its time complexity in the first approach we used was staircase approach. Time complexity was big of m plus n. Okay. And in the second approach that we did used for the same problem, name was search a 2D matrix. The second approach we used in that, time complexity was equals to big of m log n because of we deduced binary search in that. Okay. So in total, we revisited 3 problems and solved 2 new problems today. It was supposed to be solved only 1 new problem today, but we did solve 2 new problems. I think I have already done enough summarization of the problems that we did or revisited in today's stream. Okay. Oh man, it's showing that day 33, but it should be day 34, right? I will fix it. Or can I fix it like here? Okay. 34, right? Day 34. Is it change or something? Okay, it's change. Okay, we can change it in the live. So, I think I should end the stream now. So before the stream, if you make sure to like the stream, and you can consider subscribing. You all can consider subscribing the channel only if you feel that okay, we have learned something from this channel, or we are learning something from this channel, or getting some value. Then you can consider subscribing. Only after that you can consider subscribing to the channel. Okay, I will not say just directly go and subscribe. Only after I say that go man, go and go subscribe to the channel. You can consider subscribing when you feel that this guy is providing us a valuable content, or we are learning something from him. Not just DSA, maybe communication or other things. Like my communication is not much that much good, I think, but it will improve with time. Okay, but for now you all can join the Discord server, because I will recommend it because of you all can share your daily progress there, and what's like you are doing on a daily basis. You can get a review on it from other members also, and you can contribute in the community. And yeah, I'm to trying to create a community of good people who help each other grow together. Okay, like the community is not that much bigger now, but it will become bigger, I think, in the upcoming time, right? Like the number of members will increase with time. It will just take our time. Uh, and yeah, when you will subscribe to the channel, what will happen when I will be live again, or upload a new video, then you will get notification in your home feed or notification section. Then you can again come on the stream and see me solving these problems, or giving explanation how the things are working, and see me how I'm failing at problems and trying even again after that, right? And yeah, we can also have interactions in between, and we can maybe you try to solve my problem or give me hints, or maybe I try to solve your problem or any doubts you have, right? Like this is a learning public stream. Fine. And yeah, please also do give reviews in the comment section also. Like what things should I improve? What new things should I come up with? And what new things should I add? Should I change my explanation style or something? Or or anything should I change that you think that I should change in my approach or something? And as soon I'm thinking to start the CSS series very soon, right? It is being delayed from a very long time. It was supposed to be started on around 2 or 3rd of July, but I think it's already around 10 or 12 days delayed, right? And I think I will start it soon, because I also have to learn JavaScript. We also have to learn JavaScript, right? But today I will keep the stream till this point, because I also have to finish those lectures which I have told you about, right? Mm. So yeah, this was all for today's stream. We just revisited 3 problems today, and also solved 2 new problems. I think from the past 4 days we are breaking down the roadmap, right? Like we are going against the roadmap. Like on a given day, it was supposed to be solved only 1 problem. We solved 2. Or on the next day, it was supposed to be only 2 problems to be solved. But instead of that, we solved 3 problems. I think it's going on from the past 4 days, if I count. It is being around 4 days. It's okay. So in the last, I will say that till then you all have to keep learning and keep exploring. And man, you all have to just keep grinding, okay? You all have to just keep grinding. Ha. Okay, fine. Keep grinding.